Okay, so this is for the number of solutions for quadratic equations. Okay, recall the quadratic equation is ax squared plus bx plus c. Okay, and remember when we used the quadratic formula, we had to set this equal to 0. Okay, now if we were to graph this equation, we would have to make it y equals, and whatever the equation is would determine the graph. Okay, but when you use the quadratic formula, you have to set it equal to 0. So basically, when you're using the quadratic formula and you're setting this whole thing equal to 0, but this whole thing equals y. Okay, so when you're using the quadratic formula, you're actually setting y equal to 0. Okay, now if you have a graph and the right left is the x-axis, okay, and the up-down part is the y-axis, okay? So y equals 0. If you were to graph y equals 0, y equals 0 is right here, so y equals 0 would be this entire line right here, okay? So the x-axis is actually the same as the graph of y equals 0, okay? So when you have an equation in this form, okay, it's going to make a parabola, okay, and a parabola basically looks like this. It looks like a U, pretty much. All right. So when you use the quadratic formula, you're getting these x values right here. Since we set y equal to 0, when we use the quadratic formula, when we get a value for x, it's going to be these points right here, exactly where it hits the x-axis. Because like I said, we're setting y equal to 0. Okay, so these points here are called the solutions, or the zeros. Okay, the reason they're called the zeros is because we're setting y equal to 0. All right. And the solutions or zeros are the x values. Okay. So just looking at the formula for the quadratic equation, the quadratic formula, when you solve for x, you're doing negative b plus or minus radical b squared minus 4ac all over 2a. And you see right here, the part that's under the square root, we're doing both plus and minus. Okay, so you would think there's always going to be two solutions, but that's not always the case. All right. For example, if you get plus or minus 0, well, whether you add 0 or subtract 0 is the same thing. So in that case, you're only going to get one solution. Okay, so it's not always going to be two solutions as I pictured here. So I'm going to go over each one. All right. But the bottom line is the part of the quadratic equation. Oh man. Okay, here we go. The part of the quadratic equation that's under the square root is going to determine how many solutions there are. Okay? So the part that is b squared minus 4ac, that is called the discriminant. All right. I hope I spelled that correctly. So let's see the various cases. There's just 3 cases. All right, for the number of solutions. If b squared minus 4ac is positive, you get 2 real solutions and 2 x intercepts. Okay, so let me see. Okay, I'm just trying to move this. Okay, so if b squared minus 4ac is positive, you get 2 real solutions and 2 x intercepts. And it's going to look like this. Anything where it hits the x-axis in 2 different points. Okay, so those points are going to be your solutions. And x-intercept, that means the point hits the x-axis. Okay, so as you can see from this, it has 2 x-intercepts. All right, these are your x intercepts. Okay, you learned about y-intercepts where it hits the y-axis. These are the x-intercepts. So this is case number 1, when b squared minus 4ac is positive. All right. So case number 2, b squared minus 4ac is negative. Just want to make sure you understand that's a negative, not a dash. Okay? So in that case, you're going to have a negative something. You're going to have a negative whatever under the square root. Okay? And we covered that already. That is not a real number. That's an imaginary number. Right? So you're going to get plus minus an imaginary number. Okay? So in this case, when b squared minus 4ac is negative, it's going to be 2 imaginary solutions. Okay, but imaginary solutions are not real. So it's actually no real solutions and no x-intercepts. And what the graph will look like it'll be like this. Okay? It never reaches the x-axis. Remember we said the dots on the x-axis where it hits it, where it intercepts it? We said that's the solutions. Those are the solutions, right? But in this case, it never hits the x-axis. So the solutions are imaginary, okay? They're not real. So there's 0 real solutions and there's 0 x-intercepts. It never intercepts the x-axis, okay? And we have one more case we did. So when the b squared minus 4ac, that's called the discriminant. Okay, so when it's positive, 2 real solutions, 2 x-intercepts, and there's your graph. When it's negative, it's 2 imaginary solutions. No real solutions, no x-intercepts, and the graph looks like this. And finally, the third case is when b squared, this is the third case, b squared minus 4ac equals 0. Okay, so in that case, you end up with plus or minus the square root of 0. Okay, and the square root of 0 is just 0, so that's just plus or minus 0. Plus 0 and minus 0, that doesn't change anything. So in this case, you only get one solution because it's plus or minus 0. You're not getting any extras. So it's one real solution and one x-intercept. Okay, and the graph will look like this. It can be to the right or to the left. That part doesn't matter. Doesn't matter if it's to the right or left, whatever. The graph will look like this. And this point here, that is your solution. Okay, the x value of that point, the x coordinate, that is your solution. Okay, so three cases, guys. When it's positive, you have two real solutions and two x-intercepts. When it's negative, it's two imaginary solutions. There's no real solution and no x-intercept. And when it's 0, it just intercepts, there's one x-intercept and one real solution, okay? It just hits the x-axis once. So these problems are actually pretty easy, okay? Here's the graph of g of x, all right? And they're saying, is the discriminant of g positive, 0, or negative? Well, let's see. So g is a parabola. These are all going to be parabolas. Okay, like I said in the beginning, when you have ax squared plus bx plus c, that's going to be a parabola. Okay, we're going to get more into that later, but it's basically a U shape, a combination of like a U and a V. Okay, so here is the discriminant positive, 0, or negative. Well, there's only one intercept right there. You can see it doesn't hit it twice. It only has one x-intercept. So which one did we say is one x-intercept? When b squared minus 4ac is 0, that's one x-intercept. Okay, b squared minus 4ac is your discriminant. So in this case, it's 0. Okay, b squared minus 4ac equals 0. Okay, this is your discriminant. All right, so it's pretty easy. So it hits it in one x-intercept, so it's 0. There's only one solution. Okay, number 2, what is the value of the discriminant of f? Well, we need our a, b, and c, right? So we know this here is a, this here is b, and this here is c. Okay, just make sure the equation is in order of decreasing exponents. The x squared is first, the x is second, and the constant is third. So the discriminant, we said, is b squared minus 4ac. So b is positive 10. So we have 10 squared minus 4 times a, which is negative 4, times c, which is negative 8. Okay, and just use the calculator. 10 squared minus 4 times negative 4 times negative 8 equals negative 28. So you put that in the box. How many distinct real zeros or real solutions are there? Well, let's see. Our b squared minus 4ac is negative. Our discriminant is negative. So let's look. When b squared minus 4ac is negative, you have 0 real solutions and 0 x-intercepts. So for number 2, how many real number zeros, which is the same as real solutions, okay, same thing. The zeros or the solutions are the same thing. How many zeros are there? Well, there's none. There's 0, okay, because when b squared minus 4ac, when b squared minus 4ac is negative, there's 0 real solutions. Remember I said in the beginning, the points where it intercepts, those are called the solutions or the zeros. Okay? So it's really pretty easy for the most part. Okay? So here we have number 3. Our A is 3. The B is 24. And the C is positive 48. So the discriminant, they want to know, and that is b squared minus 4ac. Okay, that's just a part that's under the square root of the quadratic formula. B is 24, so 24 squared minus 4 times A, which is 3, times C, which is 48. And just use the calculator. 24 squared minus 4 times 3 times 48 equals 0. Okay, the discriminant is 0. So put that in the box. How many distinct real zeros or real solutions are there? Well, let's see. When b squared minus 4ac equals 0, I don't know how this 2 got here. It's one real solution. When b squared minus 4ac is 0, it's one real solution. Okay, so that's the same as real zeros. So it's just 1. Okay, real zeros is the same as real solutions. All right, number 4. Is the discriminant positive, 0, or negative? Well, how many solutions do we have? We have 1, we have 2. Okay, you look at the x-axis because that's y equals 0. And we have 2 real solutions, 2 x-intercepts. All right? So what do we know about the discriminant when we have 2 solutions? Well, let's see. 2 solutions, I think that was case number 1. 2 solutions means b squared minus 4ac is positive. All right? So b squared minus 4ac is our discriminant. And it's positive. So at this problem, the discriminant is positive. Okay, it'll be multiple choice. You'll see. Because we have the 2 solutions. Okay, so on this one, in front of the x squared, there's just a 1, right? So that's the A. Our B is negative 3. And our C is 18. The discriminant is b squared minus 4ac. Okay, b squared is negative 3 squared minus 4 times a, which is 1, times c, which is 18. Okay, and using the calculator, minus 4 times 18, negative 63. So you just type that in the box, negative 63. Okay, distinct real number zeros. Well, when you get a negative, the solutions are imaginary. Okay, because it's the square root of a negative. It's going to be plus, minus, and negative. So there's 0 real solutions. It's going to be only 2 imaginary solutions. Okay, so that's it, guys. It's pretty easy. just look at use b squared minus 4ac as the formula, and look at the three cases and determine which one it is.